The next few worksite hazards we'll look at occur around trenching and excavating operations. Cave-ins and objects and tools falling into an excavation are constant threats. So good job safety around trenches and excavations includes keeping tools, materials, and loose dirt and rocks away from the edges. Excessive weight near the edge of a trench or an excavation could also cause a cave-in. In general, material should be stored at least 2 feet away from the edge of a trench or excavation. To protect everyone at the site, barricades should be placed around all trenches and excavations. And all OSHA regulations and company procedures should be followed for shoring and securing a trench or excavation from a cave-in. You should never work beyond the shoring. And you should remember to check the excavation daily for signs of trouble, especially after a rain, since the water could loosen the dirt. Working near a hazard but not in direct contact with it is commonly called proximity work. Proximity work requires following procedures, caution, and awareness. Hot piping, energized electrical equipment, and running machinery can all be hazardous. In any case, you must perform your work so that you don't come into contact with the hazard. For example, you may need to erect barricades to prevent accidental contact. Energized electrical equipment is particularly hazardous. Regulations and procedures spell out the minimum safe working distance from energized electrical conductors. The distance that must be maintained varies with the voltage levels involved. Many jobs require work to be performed in close proximity to tanks, piping systems, pumps, and other components that contain pressurized and/or high-temperature fluids. Many industrial processes contain fluids at temperatures of several hundred degrees. Contact with components of these processes can cause severe burns. Any work around pressurized or high-temperature systems should be considered proximity work and dealt with accordingly. As the source voltage increases from 0 to its peak negative value, the capacitor is being charged, but in the opposite direction. When the source voltage reaches its peak negative value, the capacitor is fully charged. Again, the source voltage and the voltage across the capacitor are equal and opposing, so current is 0. As the source voltage passes its negative peak, the capacitor again starts to discharge. When the source voltage reaches 0 again, current is at its peak positive value, and the cycle is complete. Now, in the example we just looked at, capacitance was the only factor that affected current and voltage. In a purely capacitive circuit, capacitance causes voltage and current to be out of phase. Because capacitance opposes a change in voltage, changes in current always take place ahead of changes in voltage. Another way to say this is that in a purely capacitive circuit, current leads voltage by 90 degrees. Now see if you can answer a question about the relationship between capacitance, current, and voltage. If a space meets the definition of a confined space and also contains hazards that are immediately dangerous to life and health, it can be classified as a permit-required confined space. Before these spaces are entered, a permit needs to be obtained. Permit-required confined spaces are defined as confined spaces that contain or have a potential to contain a hazardous atmosphere, that contain a material that could engulf or surround a worker, that contain any other recognized serious safety or health hazards, or that is configured so that a worker could be trapped or suffocated. When you're working in a confined space, always follow your company's procedures. Following these procedures may include receiving clearance from a safety representative before starting work. At the minimum, working in a confined space requires that you stay in voice or visual contact with someone outside the confined space, such as an attendant or a fire monitor. Before starting work, make sure that the atmosphere inside the space has been tested for oxygen content, explosive gases, and other hazards. Make sure that you know and follow company guidelines for selection and use of respiratory equipment. While you're working, use only approved electrical appliances, lights, extension cords, and tools. And never attempt to perform a rescue or enter a confined space unless trained and authorized to do so. If an emergency exists, notify the proper personnel. Take a moment now to try a question on safe worksite safety practices. In this part, we'll look at safety practices for working with equipment and materials that are commonly found at work sites. We'll also look at material safety data sheets and at procedures for working safely around hazardous substances. Let's begin with safe practices associated with motorized vehicles. Many types of motor vehicles, such as trucks, forklifts, and cranes, are common to work sites. Working safely around motorized vehicles requires care on the part of their operators, but also on the part of anyone working in their vicinity. The operator of any motorized vehicle is responsible for the safety of passengers and the protection of any load being carried. Using common sense and following safety rules help prevent accidents, and the operator should have a clear view of the road. This means that windshields, rear-view mirrors, and lights should be clean and functional. When operating a motorized vehicle, you should always wear your seatbelt. Also, be sure to obey all speed limits, and be sure to reduce your speed when you're in crowded areas. When you're backing up, look to the rear and sound the horn first. If your rear vision is blocked, you'll need to get someone to direct you. If your vehicle has a backup alarm, make sure it's working. And make sure you turn off the engine and set the brakes before leaving the vehicle for any reason, including to refuel. Now, cranes and other vehicles used to lift loads require additional precautions. For example, another worker may be required to signal the driver about the position of the load or the direction of the vehicle's travel. When we talk about negative power, we mean power that is returning to a power supply from a load. We can better understand what this means by looking at a second type of AC power, reactive power. The next equipment safety procedures we'll look at are concerned with protecting you from potential hazards associated with electricity, flammable liquids, chemicals, acids, and steam. There are several techniques used to put equipment in a safe condition to be worked on. For example, tags and locks may be used to ensure that the status of a system or component doesn't change while work is being performed. In other words, locks and tags are used to make sure that motors aren't started, valves aren't opened or closed, and no other changes are made that would compromise worker safety. Tags and locks are placed on each switch, circuit breaker, valve, or other component that is operated to isolate the equipment. In this way, workers are protected from all potential sources of energy.
In this topic, we looked at some hand tools that are used to turn fasteners. We saw two types of screwdrivers designed to install and remove screws. And we also looked at several types of wrenches. Although wrenches have different designs, their general function is the same, to turn fasteners. Now try some practice questions to check your understanding of screwdrivers and wrenches.
In most lockout procedures, each lock has its own key, and the key is kept by the person who installs the lock. In general, the person who installs the lock is the only one who can remove it. When a device, switch, valve, or piece of equipment is locked out, a proper tag is also attached. Only tags that have been approved for the worksite should be used. And a basic rule of thumb is to never operate any device, valve, switch, or piece of equipment with a tag or lock attached to it. The exact procedures followed for lockout, tagout vary between different companies and work sites, so you'll need to learn about and follow the lockout, tagout procedures used where you work. Another potential safety hazard from which workers should be protected is any opening in a wall or floor. There are two basic ways in which workers are protected from these hazards. The openings are covered or guarded. Any hole in a floor should be covered if possible. When covering an opening is not practical, barriers, which you may also hear referred to as barricades, are used to alert workers to the hazard. For example, barricade tape is often used to alert personnel to hazards in an area. Typically, barricade tape is strung between 2 points, such as between poles. The tape used is color-coded according to its function. For example, red means danger is present. no one can enter an area guarded with a red warning barricade tape. Another commonly used type of barricade is a protective barricade. Protective barricades physically prevent people from passing beyond them. These barricades can be steel fence, wooden posts and rails, posts and chains, or other types of cable. The line current is actually equal to the phase current times the square root of 3. Since the square root of 3 is 1.73, we can say that the phase current times 1.73 equals the line current. You'll need to know this when you're taking readings of current and voltage on three-phase systems that are delta connected. The safe use of equipment at a work site isn't the only safety consideration you need to keep in mind. There are also many materials that you need to work safely around. In order to help protect workers from hazardous materials, OSHA has developed a standard called the Hazard Communication Standard, or HAZCOM for short. This standard addresses the worker's right to know about the specifics of any hazardous materials that he or she may come in contact with on the job. HAZCOM requires that all employers educate their employees about the hazardous materials they may be exposed to, and that employees be taught how to work safely in the presence of these materials. For example, a document called a Material Safety Data Sheet, or MSDS, should accompany every shipment of a hazardous substance and be available to the workers on a job. In a Y-connected system, the phase current is equal to the line current, but the phase voltage is not equal to the line voltage. The phase current is equal to the line current because the current flowing through each line has to flow through the coil or resistor in the line. The phase voltage is not equal to the line voltage because the voltage in each coil or resistor has to be added to the voltage in one of the other coils or resistors to form the voltage across any two wires. In Y-connected systems, line voltage equals phase voltage times 1.73. Now try a question to check your understanding of the material we just covered. Although the MSDS forms you encounter may vary, the information on this type of document includes the identity of the material's physical and chemical characteristics, the nature of the hazard it presents, precautions for the safe handling and use of the material, exposure limits, the reactivity of the material, and specific control measures.